Okay, so last time we had a look at the sine rule, and we did a few examples, one on finding a length with the sine rule, and one on finding the angle, and making sure that we're finding the right angle, whether it be acute or obtuse. Now we're going to look at our last two rules in this video. So we have the cosine rule now. And if we take our non-right angled triangle again, bear in mind these rules still work with right angled triangles, but it's just easier using the other methods that we learned before. Again, we have our A, B, C. Again, it doesn't matter how they're labeled. A, whoops, this would be B. This would be A, and this would be C, right? Now the cosine rule says that a squared, or let me put this in red, a squared equals b squared plus c squared minus 2bc cos A, right? Where A is the angle and side, where A is the side you're trying to find. So this is a good rule to use when you know two of the sides, B and C, and the angle of corresponding to the side you want to find. So A. So if we knew B and C and A, we could find this side here. But for example, if we knew B and C and knew this angle here, we can't find A because we don't know its corresponding angle. What we could do in this scenario is find B using the sine rule. But yeah, that wouldn't, we wouldn't be able to find A using the cosine rule. Okay. So another way of writing this is when we have all three sides, but we want to know the angle. And we write this as A equals cos, the inverse cos, and b squared plus c squared minus a squared over 2bc. Like that. These are the two versions of this formula we're going to use. And I'll show you how we get from this one to this one in a bit. Right. So, basically, let's start by using this first equation. Right? So in this case, we have, let's see. We have that. We have x here, that's 5, that's 7, this is 44 degrees. Now you can see, if we label our triangle, we have B and C here, and we have A, this is A. So we have all the information we need. So if we just, all we have to do is set lowercase a to be the side we want to find, basically. This would say find x. So what we do is we first off write out our equation. Like that. Okay, and now let's fill in our values. So a squared equals b squared, which is 5 squared, plus c squared, which is 7 squared, minus 2 times 5 times 7, and then times cos, not a, cos 44 degrees, like that. Now let's just find the value for this, so I'm going to put it into my calculator. 5 squared plus 7 squared minus 2 times 5 times 7 times cos 44, and that equals 23.65, like that. But remember, this is a squared, and we want, so we have a squared equals 23.65. You need to remember that we just want a, so we need to square root both sides to cancel out the squared. So we get that as our final answer, and if I put that in my calculator, we get a equals 4.86. So you need to remember to square root this after you've got your answer. Now, let's explore why we get from equation 1 to equation 2. It's the same rule, but I'll show you how we get from equation 1 to equation 2. Right? So we have a squared equals b squared plus c squared minus 2bc cos a, like so. Now what we want to do is, if you see, we're making a the subject in equation 2. So we want to get a by itself. So the first thing we can do is take away b squared and c squared. So we'll get a squared minus b squared minus c squared equals minus 2bc cos a. We just taken these two to the other side. Now we can multiply by minus 1 to get rid of this negative. So we can put a minus in front of both sides, basically. So all of these terms will change sign. So we'll get b squared plus c squared minus a squared equals, and then this whole term will go from negative to positive. We'll get 2bc cos a. And now let me switch these around. Now you can see, maybe you can already see that it's looking a little bit similar. Now we need to divide through by 2bc now to get cos a by itself. So we get b squared plus c squared minus a squared over 2bc. And now, again, we just apply the inverse cosine to both sides, giving us equation 2. So we went from equation 1 to equation 2. But this is when you want to find an angle, and you have all three sides. So let's put in the example. So we have 5 here, 6 here, 7, and we want to find x. Remember, because we want to find x, we want to label this as a. That's a capital A. And this is lowercase a because it's an opposite. Now it doesn't matter which way around you put b and c. And there we go. And find x, right? So now let's write down our formula. Like that. Okay, and then now let's just put in our values. So we get 5 squared plus 7 squared minus 6 squared over 2 times 5 times 7. Like that. And now I'm going to put that in my calculator. 5 squared plus 7 squared minus 6 squared. 5 times 7, that gives us 57.1 degrees, like so. Alright, finally, the last thing we're going to do is we're going to learn how to find the area of a triangle. Now when we have right angled triangles, we can just multiply, we can do half times the base times the height. So that times a half. But in this case, we can't do that because we don't have a right angled triangle. So what we need to do is we can use this formula if we know one side A, one angle A, and two sides B and C, like that, or we label them like this in the area formula. So we say A, B, and then this is our C. So whenever you have something like this, you can use this formula. And it's the area equals a half times A times B times sine C. Like that. So let's do an example with this. Right? So, we're gonna do like that. So here we have our angle C and our two values, two sides. Again, doesn't matter, this could be A like we've been saying, but it doesn't really matter what you label them. So, but we can say that's A, that's B, and that's capital C. Okay, so again, let's, and then it'd say find area. Okay, so let's have a look at this equation. So let's write it down first of all. And now let's fill in our values. So we have A as 231, B as 150, and C as 123. And that will give us sine 123, an area of 14,530. Yeah, and remember, if these were in meters, for example, this would be in meters squared because it's the area. Okay, let's do some, I'll give you some exercises. So the first exercise will be that's triangle. So this is 94 degrees. This is 40 degrees. This is 10.5. And this is x. Right. So find x. Right. For a second example, this is 28 degrees. This is x. Find x. And final exercise. This is 1, 2, 3. Oh, wait. Sorry, my bad. This is 25. And this is 10. 7. Find area. Okay.